Okay, so this will be the first video for the exam review. We'll be going through different problems in the practice exam. I'll probably try to keep them pretty short, so this first one will probably only go through the first 5 questions or so. So we're going to start with practice exam A. Oop, I didn't mean to have this there. We'll use that later. So you're given this small data set. We got 5 observations. We got some quantitative variables over here, some qualitative variables here. The first question we have is, what's the mean age of these fighters? So this is the question I always say. I hope everybody gets this right on the exam. This should be a relatively easy one. If we look at the formula sheet, we can even remind ourselves the way we find a mean is we add up every single observation, the value for that x variable, and then divide by the total number of observations we have. It doesn't change for whether or not we're looking at a sample mean or a population mean. It's the same process. So if we look here, we've got this age variable. First of all, it goes from the lowest is 28, the highest is 41. The mean is a measure of central tendency, so it should be somewhere in between our highest and lowest values. So right away, A and B don't make any sense for us, right? Because they're greater than 41. So the next thing we do is, okay, I'm going to take the first observation's value of 28, add to that the next observation's value of 37, continue to do this until I get to the very last observation, which is 32. I then divide by the number of numbers I added up there, which is 5, right? And that should give me the mean of 35, okay? So that one should be pretty easy. You know, the one mistake sometimes people will make is instead of dividing by n, they divide by n minus 1. That's not the case in the mean. That has to do with the variance and the standard deviation. So to find the mean, we simply add all the numbers up and divide by the number of numbers that we had in our data set. If we then want to find the median weight, so we're now going to be using this weight variable, right? One way we could do this is we said we could order them. So I'll just write these down. If I had paper, I'd write them down here. So 143, 155. So I'm just writing them down from smallest to largest, right? I then cross off the highest, cross off the next lowest, cross off the highest, cross off the next lowest. If I do that, right, these would be crossed out. In fact, I could actually do that here. And we're left with that middle value of 185. All right. Now I'll show you something a little bit different. If I had given you an even number data set, so let's say we had another observation and we wanted to find the median. Let's say we had a 170 in there. When I get down to the middle, I'm going to be left with 2 values. So if we had an even number data set, there was one more step, which is just we would add up whatever those 2 values were in the middle, divide by 2, right? Find the average of these 2 essentially. But we didn't have this 170, so there we are, right? The next question is, how do I find a sample standard deviation for height from this data set? And I'll give you an assumed mean. So to find the variance or find the standard deviation, we also need the mean. So I'm making sure that you don't make a mistake there. I'm giving you the mean, so we're all kind of starting off on the same place, right? So the mean we have here is 771.6. I go to my formula sheet. It reminds me, here's my population variance, sigma squared. Here's my sample variance, s squared. Here's my population and sample standard deviation, which were just the variances, but we took the square root. Okay? So I'm going to go through every single observation, take the value for that variable x, subtract the mean, and then square it. And then once I do that for every observation, add them all up, and then finally divide by n minus 1. Here our n was 5, we had 5 observations. And then to find that standard deviation, the final step will be to take the square root. Okay? So if I'm looking at this data, I just start out, I take 69, subtract that mean of 71.6, square it, add to that 74 minus 71.6 squared. So I'm just going to start typing those out. So 69 minus 71.6 squared plus, what was the next one? 74 minus 71.6 squared plus 73 minus 71.6 squared plus 74 minus 71.6 squared plus 68 minus 71.6 squared, right? So this will give me my numerator. I'm then going to want to take that. Let me see if I can put this into an equation so you can kind of see this here. I'm then going to divide that by n minus 1, which my sample size was 5, minus 1, so I'll divide it by 4. That should give me, I believe, 8.3. But the final step that I had was I also need to take the square root. Right? So I can do this in intermediate steps. Like I could just put this into my calculator, create another column, and then write that number down here. Just put this portion of my calculator, write that number down here. Do that for every observation, add them all up. Whatever that total is, write that number down. That's what's in my numerator. Then divide by 4, and then take the square root. You can break this up into steps if you want. That might make it a little easier. But once we do this, we should get 2.88. Now, if you made the mistake and you forgot to subtract 1 in the denominator because it's a sample standard deviation, I believe the answer you end up getting there should be 2.58 because you divide by a larger number. I think you get 6.64. So these are kind of trying to be trick answers where that's what it would have been if you forgot you were supposed to subtract 1 from the number of observations for a sample variance or sample standard deviation. Okay? So there we got the answer of 2.88. The next one is going to be a weighted mean example. And so as I'm typing things out here, it's kind of pushed my answer D. So I'm just going to, it's off the screen, so we'll just make sure we can see everything here. So I'm given a bunch of different categories, the weights of each category, and then the score the student got. And then ask what's the student's weighted score. So I'm trying to find this weighted mean for the score variable. Right? Well, each category has slightly more influence, right? The homeworks have the most influence. The midterm exam has the least over that weighted mean, or on that weighted mean, I guess. But remember, we're still finding a weighted mean, and so the scores, the highest score is 95, the lowest is 68. Our mean should be somewhere in between those two. So 321 doesn't make sense, 25 doesn't make sense. We can cross those out right away. We're left with two values, right? So I'm just throwing darts here trying to guess. I should be guessing either B or C. Now to actually find what this is, we'll go to our formula sheet. Looks like it's not here. Here we go. Here's our weighted mean and our weighted variance equation. So I'm going to go through and to find that weighted mean, I'm going to take each kind of group data observation or each observation for the variable x I'm interested in, multiply it by that category, that group's weight, do that for every observation, then add them all up and divide by the sum of my weights here. So that process, I could create another column, right? And I'll actually do that here so we can see what that would look like. And you could just do this, you're going to actually be writing this value down. So here it's going to be W times X. Nope, I switched over on accident, sorry. So W times X. We're then just going to take 20 times 75. Whatever that value is, we'll write that number down. 40 times 94. 15 times 84. 25 times 68. We're then going to add all these values up, right, and then divide by the sum of our weights. So if I'm typing this out here to make it a really long equation, 20 times 75 plus 40 times 94 plus 15 times 84 plus 25 times 68, right? Right, once I add those up, that would just be represent my numerator. I then need to divide by the sum of my weights. So the sum of my weights here, I need to add up my weights. So I add 20 plus 40 plus 15 plus 25. And this should give me my weighted mean, right? I think if we do that, it's 82.2, but I've got the answer here. Let's just double check I'm remembering this correctly. Yeah, it should be 82.2 once you enter that into your calculator, okay? So those are the first four problems. The other things that you might expect to see in the exam that come from here is know how you could also find a weighted variance right? So kind of review some of those questions as well. Up here, know that there's a difference. If I have a population data set, I would only divide by n. If I'm looking for the variance, I wouldn't take the square root. Another thing that I left out as a measure of central tendency is the mode here. That's because in this data set, there's no repeated numbers for height or weight. But if I asked you for the mode of age, remember the mode was the number that happens the most frequently, or that happens the most number of times in our data set. So if we wanted the mode for this age variable, the only repeated value is 37, so the mode there would be 37.